We're going to simulate what a spectrum might look like from a polymer for a given acquisition mode, which is defined by this survey spectrum that's been taken from gold. So the first thing I'm going to do is prepare a background and a set of component peaks characteristic of the material I'm interested in looking at. But in order to prepare a VAMAS block for simulating such a measurement, the first thing I want to do is I'm going to set a value which is 0 and then copy this. So now I've got another VAMAS block which has just got 0 in it, and that will have all the characteristics in terms of acquisition conditions of the original survey spectrum. And what I'm going to do now is build a spectrum, a synthetic spectrum based on a background which is a U4 background, U4 Tougaard background, and it uses these parameters here. If I wanted to have different backgrounds, there are different predefined background types, so if I was interested in germanium I could have picked this one, and when I press update you'll see the cross-section fields update for a cross-section that will be appropriate for germanium, or as we're going to do, we'll use a polymer, and then we're going to return it to the U4 background type so that we could actually adjust these parameters rather than, so if I set that to 366 it will accept that, and that will be the background that it will be defined. So let's go back to what it was, 396. So having got a background defined, you define a tag. So we're going to say this is a CO type polymer we're going to prepare, and this is going to be, we'll just call this the region. That doesn't really matter, the name, but this tag field does matter. I'm going to use this in components that I'm now about to define. So if I create a component, I can give a position which is 285 if I want this to be C1s, and I will need to change the interval for the full width half maximum, so I can set a value of 3 for the full width half maximum. So I've set the position, the full width half maximum, let's set an area of say 5,000. And in order to see now that peak, I'll just use a little trick here and replace my envelope, which actually does two things. It shows me an envelope that is calculated from the line shape that was used. So that has been the line shape that has been used to define this peak, and also you can now see there's a calculated loss structure that's associated with this peak based on the background type. So now what we need to do is add more peaks, but before we add the peaks we need to copy the tag field and enter it into this peak, because the tag field associates the components with the region which will be used to calculate the background. So let's copy and paste, and this one is going to be oxygen. So having selected having created an oxygen, we first of all need to put it at the binding energy of oxygen. So let's say 530, and we also need to set the area, and we can set the area using the area of the carbon, and we need to multiply by the relative sensitivity factor. Now if carbon has a relative sensitivity of 1, then in Schofield cross sections an oxygen peak should be 2.93. And having got that and the same tag field, what I need to do now is see what that looks like. So I'm going to undo and then go here and replace by envelope again. So now I've got two peaks. And I think just to make it look more like a spectrum, I'm going to add a third one, and the third one is going to be the valence band. So I've got a constraint here, so I will copy the oxygen and paste that, and we'll set that to be the valence band, and we'll set the position to be 0. Okay, it's a polymer, so let's make it 5. So we'll also set the area to be a very small proportion of the carbon peak. I don't know what the area ought to be for this one, but this is just for the exercise. So now, having done that, I've got 3 components, each with the same tag field as the region, and if I go to the test data tab, I can then press the create spectra from components button, and what that will do is simulate a spectrum from the information that's been defined. You could also add noise if you really wanted to make it look like a spectrum.